for that culture, as well as for this event. This is something that I think he dreamed up with the team 9 years ago, to try to just share what we know, introduce you to so many of our great partners, and to just make this available for you throughout the day. So with that, please join me in welcoming Ed Laprade.
We've got some different things we're going to talk about this morning, some things that you probably don't normally get the opportunity to really think about, because you're busy in your day-to-day, just trying to get through the day, and there's some things that are out there that they're there, but maybe you really don't get a chance to really think about them or explore them. So hopefully get the creative juices flowing today. How many of you out there feel that technology is moving at such a fast pace it's near impossible for you to keep up? Just raise a show of hands. Okay, quite a few people. How many people, by show of hands, would say that the world in general today is moving just so much faster than it was maybe 10 or 20 years ago? Another show of hands. Okay, a lot of hands. Let's think about this. And for those of you who probably can't read it from the back, the world is too big for us. There's too much dying, too many crimes, casualties, violence, excitement. Try as you will, you get behind the race in spite of yourself. It is an incessant strain to keep pace, and we still lose so fast that you stagger in hopeless bewilderment. The political world witnesses new scenes so rapidly that you're out of breath trying to keep up with them. Everything is high pressure. Human nature cannot endure much more. And that was in an article appearing in the Atlantic Monthly magazine. But the gotcha here is, it's in the 1800s. So, at the end of the day, it's all relative. Something called the Internet of Things, if you haven't heard that term before, and many of you I'm sure have. And what that really means is we're going to connect everything. Everything that's out there is connected. And how do we do that? And why do we have this thing called the Internet of Things, where everything is connected, whether it's hardwired or wireless? We have all these connections. Well, what's made it possible is advances in science that allows us to really miniaturize things a whole lot more, and cost decreases that have just allowed us to really have sensors that we can put everywhere. This Internet of Things is really being driven by sensors, and we're embedding them in objects, and we're networking them all together. There's a few different ways we can categorize it. So one way is information analysis. And in that category, we have something called tracking behavior. What might we do with sensors and tracking behavior? Well, think about the insurance company who maybe puts a sensor in your vehicle so they know how you drive, where you drive, and when you drive. And base their premiums on that, and not some arbitrary sort of thing, such as you're a male 18 years old. So therefore, we're going to charge you a mortgage to actually insure your car. How about enhanced situational awareness? Well, if I'm a police officer and I'm walking into a situation, I probably want to know where the sniper was coming from. So sensors can tell us that. And then sensor-driven analytics, maybe in the healthcare arena, where I swallow a pill, which is really a sensor, and it gives feedback about all those things going on in my body, and it just collects all sorts of data, and then later on I can analyze that data and determine my health. Another way of categorizing the Internet of Things is automation and control. And the first one, process automation, and many of you maybe aren't old enough to remember Lucille Ball and the Lucille Ball Show, but I do remember the Lucille Ball Show. And I remember this one scene where they get this conveyor belt going, and the conveyor belt starts going faster and faster, and it can't keep up with it. So how do sensors come into play? Sensors come into play where we know where those objects are, and we can adjust the process based on where those objects are, based on how much was mixed or hasn't been mixed. Another method is optimized resource consumption. What are we talking about there? Well, think about when you use electricity. There are times in the day where it's more or less efficient to generate electricity. So what if you were charged, your electric bill was based on when you used electricity, not just how much electricity you used? And what if you had a smart meter in your house, which you could tell what it was costing you at that point in time to actually use electricity? You might adjust your habits in terms of how you use it. Then the last one, complex autonomous systems. The easiest way to describe that one is reacting to things that are totally out of our control and unexpected. Think automated crash detection systems, automatic braking systems. So what's the definition of small? So if I would have held this up 20 years ago, instead of holding up all these things, you might have looked at this as being very futuristic and being very small. And what you see in the picture, I can now put in my pocket. So we've come a long way in the past 20 years. What's next? We're on to wearables. We're actually on the brink of an explosion in wearables. Widespread adoption. We're not there yet. You see them out there now. If you go to Samsung's site, you'll see a Samsung wearable. You'll see them in various places. For example, how many people have a Fitbit? Okay, there's at least one fit person there. So Fitbit, that's a device, it's basically a computer that you wear, and it kind of monitors what's going on in your body and gives feedback, and you look at your iPhone later and determine whether or not you need to exercise more or less. For me, it's usually more. But where are we going with wearables? Entirely new business models are going to pop up. Do we know what they are? Not necessarily. We haven't gotten there yet. But expect new business models. Expect those business models to change how we do things. Access to prohibitive environments. Think of a scenario where you've got a technician, maybe he's climbing a 100 or 150 foot tower. Maybe it's a cell tower. And he's got to do some work, some sort of repair work on the top. And he's up there, and he needs both hands, imagine that, while he's working. And now he needs some documentation on exactly what he's working on. Basically needs the owner's manual. How's he going to do that? Does he bring a laptop up there with him? Probably not. Does he bring an iPad? Probably not. Does he bring a Surface? Probably not. iPhone? Android? Probably not. He needs both hands free. How about if he's wearing glasses, and in those glasses he can pull up that documentation and see what he needs to see while having both his hands free. So it lets us get into environments we might not have been able to get into with a traditional device. What are some of the risks? Well, there's a lack of standards in the industry right now. Wearables are just coming out. There's really no set standards. So if you go down one path and then you decide you need to move down a different path, you might be starting all over in terms of the knowledge you've gained and invested into that technology. Privacy, there's probably going to be some pushback. Think about employees who don't necessarily want to be tracked everywhere they go. Some thought's going to have to be given to exactly what that wearable does and how that affects the privacy of the individual. Security probably takes it to another level. We're just getting our arms around mobile phones and iPads and the like, tablets, and now this is even smaller. Okay, some examples. Healthcare. A pill that you ingest and it communicates with a patch that you have on your arm that then communicates with an iPhone. Collects data on what's going on in your body, and then something that can be analyzed later. Wardrobe, smart socks that track your exercise. Awesome. Reeboks, check light beading. Measure the intensity of blows to the head. It might be something most husbands could use. My favorite, diapers. Tweet parents when they need to be changed. I'm not a grandfather yet, but someday I will be, and when I am, I want that one. If I'm watching the kids, I want mom and dad to know when the diapers need to be changed. Smart glasses with augmented reality. Augmented reality is essentially overlaying in your line of sight something that's not part of really what's there. So it's augmenting the reality. And how can you use something like that? Well, one company's looking at a scenario where they train their salespeople on new features of an automobile, but they don't typically sell some automobiles that frequently, so it's time to explain the features they can't remember. So they came up with this whole training plan, and then they had, the typical iPad kind of application, and that was cumbersome. So now they're experimenting with smart glasses, so that when they're looking at the feature, it will tell them and show them how to actually work that feature. So augmented reality. 9.6. That's the average number of SaaS applications that enterprises expect to be using in 2013. The real important part of this number is only 18% of those first wave of adopters of movement to the cloud actually replaced an application. That means 82% of them were just augmenting, adding on to what they already had. And it was only 9% were full replacements in the second wave of adoption. Why is that important? Well, it's important because if the bulk of the people that are moving to the cloud are not doing full replacements, that means there's a reason, more and more of a reason, to have to integrate to those applications in the cloud. The number one adoption concern, security. It's obvious. The number two adoption concern of moving to the cloud was integration, stability, and reliability. So if you're going to have to integrate to that cloud application, how reliable and how stable is that integration? Why do you need to integrate? Well, if you don't integrate, you end up having siloed applications or siloed data. So imagine having an ERP system with all your customer base in your ERP system, and then you decide to go to a cloud-based CRM system, and the two aren't connected. The islands of data. And it's always a challenge. You really want to integrate. So the vendors out there are recognizing that, and they're starting to put together pre-integrated cloud services. So some examples are some of the ERP players, they're supplementing their core offerings with integrated offerings. So an ERP vendor might supplement with an HR system or with a CRM system as well, with the integration already done. They're building storefronts of complementary solutions out there. It's in its infancy, but integrators, ERP vendors, cloud providers, they're starting to get together and provide total, complete solutions. But at the end of the day, integration is still your problem. Buyer beware. Some things you need to think about if you're moving to the cloud: extensibility. How easy is it to get information in and out of your cloud? So if you're going to have to integrate, what are the APIs, the data structures? Are they there? Are they, to use a word somebody I know very well, are they robust? Are they backward compatible? Portability. What's the ease of integrating to and from the cloud? So you decided to move to the cloud, you've integrated the cloud, you got there. Can you get your data out after? You're not necessarily going to make the decision to go with a cloud provider and spend the rest of your life there. You're probably going to end up moving at some point in time. Can you move? Reliability, performance of the service. That's not just the service itself, but the integration that is done to your core systems. Do they scale? Does your core system and the integration you've done scale? Standards. You need to create some standards for yourself. When you're looking at the cloud and you're looking at where you want to put your applications, you need to start developing standards of what's important to you and what you need to look for. Analyzing big data. We're in the midst of a data explosion right now. And some of the things I've already talked about, a good example is the Internet of Things. We've got all these devices out there, and there's sensors, and I talked about sensors. What are those sensors doing? They're capturing data. And they're bringing that data back someplace. So back in 2011, we had 1.8 zettabytes of data. And in case anybody cares, it's 1 trillion gigabytes. And if you really care, if you were sending 3 tweets a minute, and every person in the U.S. was doing it, it would take something like 23,000 years to actually collect that much data. Crazy numbers. But the reality is we're collecting a lot of data. But what is big data? Big data, from the perspective of the user, is that data that's too large to use either the application we normally would use to process it, or those tools we would normally use to analyze it. It's just too big, so we have to do something out of the ordinary. So with all that data out there, we welcome in the era of in-memory. The in-memory revolution is kind of where we're at right now. And with in-memory technology, what we're able to do is crunch massive amounts of data in real time. What is in-memory technology? Well, basically what we did is we got rid of the hard drives. If you've never cracked open a hard drive and looked at the internals, it's nothing more than spinning disks, and they got these read-write heads that float over those spinning disks, literally float. And when you need to access data, the read-write heads might be over here, and the data you're looking for is another part of the disk that's got to come back here. So when you turn on your computer and you're booting it up and you hear that buzzing noise, that's those read-write heads going like this. It's mechanical motions. It takes time. So what we've done is we've replaced these hard drives with solid-state memory. And, well, solid-state memory's been around for a long time. Why haven't we done it before? It's just too expensive. But the prices come down, and as prices keep coming down and densities keep getting higher, we're able to actually start moving some of that data into memory. Hence the in-memory revolution. We're also doing some other crazy technical things that I won't get into, with shifting from row to column-based storage, but that's for the technocrats. You and I, we can understand moving from hard drives to solid-state devices. And anybody who's bought a laptop recently, if you elected to go with a solid-state drive instead of a traditional hard drive, you'll know what I'm talking about in terms of speed. A lot faster. Now, some vendors are claiming 1,000 to 20,000 times improvement in query speeds. Like anything in this industry, your mileage may vary. So what if you can close your books in 7 seconds instead of 7 days? How would that affect your business? And what about the holy grail of data? So some of you out there may have something we call a data warehouse. Some of you might be thinking about building a data warehouse. And really what a data warehouse is really just another place where we keep the data, because we're going to have massive amounts of data. We want to analyze it, and the easiest way to describe why we do this is use an example. The example would be, let's assume I want to analyze sales over the past 10 years, and I'm going to run a query, and I know that query is going to take a half an hour to run. Well, if I did that on my production system, where everybody's trying to enter in orders, and I brought it to its needs, I probably have a few angry people out there, right? So what we do is we move the data off into a data warehouse. We can analyze it, we can beat it up all day long. What if you didn't have to have a separate database for that? What if you could do it all part of the same database? Maybe that's coming down the road. ERP vendors are starting to add in-memory technology to their applications. There's a war going on right now between SAP and Oracle in terms of who's got the fastest and who has the most built into their applications. Gartner's predicting that 35% of large mid-sized companies are going to be using in-memory technology by 2015. That's just around the corner. Exponential. What are we talking about here? There are some technologies that are out there, they exist. They're actually in use here today. They're not mainstream, but they have the potential of exponentially impacting our business once they do become mainstream. So we'll talk about a couple of those. Artificial intelligence. It's been around for a long time. It's nothing new, right? You've heard of artificial intelligence. HAL, the computer, the Space Odyssey. But it's getting a lot of play now, and for one specific reason, a lot of the low-cost computing, a lot of distributed computers, the cloud, all those computers out there in the cloud, we're able to process a lot more now. So artificial intelligence is becoming more of a reality. It can help us improve predictions. It can help us in problem solving, administrative tasks. It's already being used in manufacturing, healthcare, and the military. IBM's Watson, I could just dump another $1 billion into Watson, which is yet to really make them any money. If you want an example of how front and center it is, all you have to do is go to IBM's website and see what they're doing with Sloan Kettering Cancer Center in terms of training Watson to help doctors with treatment of cancer. Robotics. This is an area that's really, it's out there, it's been out there. We all know that cars, if you were to look in Detroit, there's big robots out there that are essentially on manufacturing floor that help build things. But they have the ability to fundamentally change how we work. For Amazon, 18 million square feet of warehouse space, and the bulk of it's done by, the picking, packing, and shipping is done by robots. Can you imagine, for us older folks in the audience here, a pill-sized camera, so no more colonoscopy. All you have to do is swallow a pill, all the information comes back to the doctor. Remote healthcare, virtual consult, or how about surgery, where the doctor is still in control, but the robots can make more precision cuts. More autonomous cars make deliveries. Nobody's driving them. What kind of impact would that have to the world and business? Prediction is that 45% of U.S. jobs are going to be automated in the next 20 years. Entire job categories are going to disappear. So you need to think deeper about this in terms of where some of this is actually going to happen, because it's going to affect a very wide section of the industries. Cybersecurity. Did you know hackers are available online for hire? Seriously. Need a few credit cards? Behind on some bills and want to get a few credit cards and use somebody else's? Go online and hire somebody. You really don't want to go online and hire somebody because you think they charge too much? And you want to do it yourself? They'll sell you the software. You can go online and buy it. It ain't going to guarantee results. 80% of the card numbers you get back will be valid. Serious. The Internet of Things. Every car, appliance, piece of office equipment is going to be linked and ready to track. Add to that, as we move into the wearables, watches to EKG monitors are also going to be linked. Kind of creates a security issue. Take one example from U.S. Chamber of Commerce. So they had these copiers. In the past, all they really had to do was worry about people disguising themselves as service technicians. First of all, how many people realize that copiers have hard drives in them that have copies of everything that you copy? Okay, quite a few people. If you didn't know that, you really should know that. To get rid of your copier, you really need to make sure the hard drive's light. So what they would do is they would send People disguised as service technicians in to steal the copiers and extract all the information. Well, what they did is they hooked their thermostats up to the internet so that they could do remote monitoring and that sort of thing. Well, the hackers hacked into that and accessed and breached the copiers. The only reason why they found out is one of the hackers kind of made a mistake and actually sent a bunch of things to the copier to be printed. So how do we prevent? We need to look at risk prioritized controls, risk awareness programs. We need to build resilience into our systems. If we go down, we need to make sure we can get back up quickly. So let's talk a little bit about our approach. Okay. The view from the business world in the past may have been a little bit like this, and in a lot of cases still is, depending on the organization. The view of the IT department is a line item cost to be managed and in some cases squeezed. The lower we can make that line item, the better. Okay? Then the view from the other side, from the IT department, maybe not a whole lot better. And I'll read this to you because you probably can't see it. I'm getting reports that you're being arrogant in meetings. Got a little builder. That's because I have a deep understanding of technology and a moral obligation to keep simpletons from ruining the world. Maybe you could tone it down. There's no kill switch on awesome. So we had a little bit of a disconnect between the business world and the IT world and how they interacted together within the same organization. So how about a little bit different view? How about if, from the business perspective, we look at IT as a strategic part of our business, and we treat it like a strategic part of our business. We involve it in those meetings and those sessions where we're making business decisions and strategy decisions. Because going to IT after the strategy has been baked is probably a little bit late. And from the IT side, how about if we think like a venture capitalist? Okay? Venture capitalists, how do they manage things? They have a portfolio investment strategy. And in the IT world, I'd be managing a portfolio of projects. Objectives, dependencies, status, finances, associated resources, risk profiles. Those are all things that are important to me if I'm managing projects. If I have a dozen projects on my plate, do they all have the same risk profile? Do they all have the same cost? Do they all have the same net benefit? No. Can I do them all in the current year? Probably not. So I need to balance that portfolio of projects. Also, I need to look at valuation. I need to know the performance of each asset that I have and of each project. How did they turn out? I need to communicate to the business side of the house not only quantitative, but qualitative value. So not only what did it cost us to do this, but what was the value we got out of doing that? It's a different way of looking at IT. We also need to consider something called technical debt. And what is technical debt? Well, it's really just a way for us to kind of refer to something that kind of exists here. A lot of us might talk about legacy systems, legacy applications, how they're dragging us down. There's debt on our balance sheet, if you will, in technical terms. I can't tell you how much time we spend as an organization going in, breathing life into those old systems. It may be worthwhile. It may not be. So each year when you're looking at the upcoming year and you're planning out projects, how much technical debt are you going to remove so that you can go on and have new projects in new things to actually move the business along? You know, the strategy of buying the computer, keeping it for 10 years, and not upgrading for the last 7 years is a lot more expensive than you might imagine. Finally, managing the cloud. Who's going to be your cloud services broker? So you decided to move into the cloud, right? Is it your IT department? Do you have an IT department? Is it a partner or vendor? Somebody needs to be your service broker. Somebody needs to manage the integration, the security, the data, the business rules. Somebody needs to, I talked about standards earlier, somebody needs to make sure their standards are in place and that you're following the standards. In summary, talk about connecting in different ways, talk about different technologies. There's a lot of different things out there. Hopefully I've just brought a few up that maybe get you thinking on a different plane. We've got some great presentations here today. And take advantage of them. Think about where you are, but more importantly, think about where you want to be, where you're headed. And maybe stretch yourself a little bit in terms of your thinking. And attend a session that maybe you wouldn't have attended in the past because it's different. It's not that technical, need to get it done right now, but it's forward thinking.